So, hi everyone. I'm Kushwaha. I am the ex-president of the CP division of Programming Club, and I'll be your tutor for today, giving you an introduction about C++ STL. So, STL is Standard Template Library. It's one of the most important features of C++, and one of the reasons why C++ is so widely used in competitive programming. Uh, so the goals for today will be to learn about the main containers. Containers meaning data types that STL has. There are pairs, vectors, set, unordered set, and map and unordered map, and the various functions that we can carry out on these data types. So basically the importance of STL is that it makes our job very easy using the tools. Suppose we have to write a sort function in some problem. To write an efficient implementation of that, it will take a lot of time for us. But if we use STL, it just takes one line of code. And similarly, there are many other applications where it saves us a lot of time and gives us an efficient solution. And the other thing is this STL learning STL is very easy. All one needs to do is just get an introduction of it, and everything is readily available on the internet. You don't really need to understand anything to use it. So, and also in my experience, I have seen many people that if they don't know about HTL, they find it very hard to do questions, and sometimes they just give up. Uh, so there's really a stark contrast between people doing CP before they know about HTL and people doing CP after they know about HTL. It just becomes very easy. So this was the importance why we are learning this. Right. So this is about STL. As I said, this is basically a set of C++ functions and classes to perform various tasks. These are more efficient, bug-free, and easier to use than something you'd implement by yourself. So the first container we'll be learning about are pairs. Pairs are used when obviously you have to store a pair of numbers, pair of related numbers. For example, you have to store a time range. You have to store start time and end time, and you have to store them together. So you'll use pair for it. Uh, an example of where you would apply this is if you want to sort the time ranges in such a way that it first gets sorted by the first number, and then if the first number is same, it gets sorted by the second number. So without pairs, it really becomes a difficult job, right? uh, how will you do it without pairs? Can anyone tell me?
We will make two arrays.
Right. Then
Then we will check for both the indexes of array simultaneously. Then we will sort.
hmm. Not simultaneously. You'll first check for the first number because you need to first check that if the first numbers are equal, then only you'll check for the second number, right?
Yeah.
Hmm. So this becomes a little bit difficult without pair. With pair, you can just use the inbuilt comparators as I've written inbuilt less than comparator and sort using the STL sort function. It just becomes a matter of one line of code. Any questions about pair?
Can you give one more example, like where to use?
Hmm. So, one example was obviously time range, as I said. Another example is suppose you have to sort some points on the 2D plane such that if the x-axis uh, you have to sort them by x-axis, and if the x-axis are same, you have to sort by y-axis. So basically, you have to do a grid-wise search of the points on the plane. Then you can store the x coordinates and y coordinates in the pair and just sort it. it becomes very easy. Not only just sort, all functions become very easy if you use pair. Is that all right?
Oh, okay.
Hmm.
Okay.
So next is vector. Vectors are basically an enhanced version of arrays. They have far more features than arrays. Uh, so right now, when people start coding, they use arrays, and it does the job most of the time. But when you have some advanced questions, or you have some advanced functions to run on a list of numbers, arrays come short, and you have to code. Sometimes you have to code by yourself if you are using arrays. So for that we use vectors. To understand vectors, there's another thing we need to understand, that are iterators. Iterators are nothing but a variable that store positions. Uh, so for example, we have, for the first position, we have v dot begin. Begin function returns the first position, returns a variable that stores an iterator that represents the first position. Similarly, there's v dot end. V dot end returns the last position. And one of the main reasons why we use vectors are, for example, in an array, you need a fixed size, right? In vectors, you don't need a fixed size, so you can just push back an element to the last, after the last element of a vector, using v dot pushback. Uh, and v dot popback removes the last element, and v dot empty checks if the vector is empty or not. So as you can see, there are a lot of these are all inbuilt functions. There are a lot of functions implemented for us. Similarly, v dot insert takes in the iterator and the value, and inserts the value at the position of the iterator, at the position that the iterator is storing. Mm. And v dot erase removes the number at the position of the iterator that's passed to it. V dot clears the whole array. Any questions about?
Here the position is in the form of memory location or the like 0, 1, 2, the like in arrays it used to be.
Memory location.
Okay.
So vector you can store the position in both ways. So you can also use v naught. V naught will also give you the first number, and you can use v dot begin. V dot begin will also give you the first position, and I'll just give you an example once. So here is an implementation of a vector. I have initialized n as 5, so I'll be storing 5 numbers in this vector. You can see the code, right?
Yes.
Yes.
Hmm. I'll be giving the input of 5 numbers. This is the iterator that I initialized. It stores the first position. Any doubt in this code?
Why it's written auto there? I mean,
So auto keyword is basically uh, it uh, when you normally initialize a variable, you have to write its data type, right? Suppose int n equal to 5, you have to write its data type as int, right? But using the auto keyword, it figures out the data type of the variable automatically. So you can also write auto here, n equal to 5. So the code will figure out what the data type of the variable is, using the number that's initialized to it. So 5 is integer, so n will be an integer. Similarly, a dot begin is an iterator, so it will be an iterator.
okay, okay, okay.
Hmm. So this here right here is the for loop. For loop starts from obviously the first position, and it ends before the ending iterator. So here I have put in the check that iterator is not equal to a dot end. One thing to note here is a dot end does not represent the last element. A dot end represent the position after the last element. Any doubt in this? The for loop.
लाइक ऐसा होता है कि जब हम लोग एरे में करते हैं,
हम्म
अगर पोजीशन लास्ट एलिमेंट का है तो
हम्म
हम लोग लाइक अगर 5 एलिमेंट है तो पोजीशनिंग तो 0 से 4 तक होती है ना।
हाँ हाँ
सो
वैसे ही।
जब हम लोग फॉर लूप लगाते हैं तो हम लोग लिखते हैं कि जो लास्ट वाला होगा n नॉट इक्वल्स टू 5 होना चाहिए।
हम्म
सो हियर वैसे ही लेगा क्या लाइक
हाँ वैसा ही
एंड
है।
का जो पोजीशन है वो एक कम तक जाएगा आई मीन
हाँ
वही
हाँ
वैसे ही है ना।
वैसा ही है वैसा
ओके
ही है।
ओके ओके ओके।
Hmm. And another thing to note here is here I have not I am not taking the output of the iterator. I am taking the output of the value of the iterator. This star is the value of operator. IT will just store the memory address of it. The iterator, it will just store the memory address of it. We don't want that, right? We want the value of the memory address.
Value of the address means like
Value
the
that's
exact.
stored in the address.
Okay.
So the advantage of here is this. Suppose I have to sort the five numbers that I have written. With the if we do not use the vectors, we'll have to code this manually. We'll have to code the sort function manually, and even if you code it manually, if you use bubble sort or any algorithm like that, the complexity that will come will be n square, which is not efficient. We want n log n, right? You have an idea about complexities, right?
Yes.
Basically, we want the fastest version that's possible. So sort does that for us. Uh, the parameters of for sort are the first iterator and the last iterator, right?
Here about this last iterator, like suppose we compare to array. So if we have 5 elements, then it is from 0 to 4. Then does a dot begin store the address of the 0th element, and a dot end store the element, I mean address of the uh, fifth element. Like we have 5 elements, so it will go from 0 to 4. So a dot end stores the address of fifth element, then mean address after the last element,
Yes,
or
correct.
which okay.
Hmm. It will store the address. It will store the position after the fourth element, but it will be empty, right? So if you do see out a
Yeah.
dot end, it will not return anything because it's
Uh-huh.
really a position after the last element.
Okay, yeah,
Hmm.
clear.
So suppose here we have sorted all five elements. Suppose you want to sort the last four elements and leave the first element as it is. Can anyone guess what we'll do? What will change here?
A dot begin plus 1.
Right. Because sort function takes in the takes in the range that needs to be sorted. So we'll just change the range. We'll just do +1 if we want to leave the first element as it is. And here again, I've used the same iterators to output the result. So in vectors, you don't necessarily have to output the elements like this. I've just shown this to explain you about iterators. Just as you do in an array, you can also do this. Just a normal for loop, a normal cout. So first I'm taking the output as it is, and then I've sorted the array. And then if you change the range to leave the first two elements as it is, it will only sort the last three elements. So this was about vectors. I think this all you need to know about vectors as an introduction. Obviously, there's a lot more, but For introduction, this is enough. You'll find more information on the net as you need, and as you solve questions, you'll learn more. Any questions in this vector? Okay, so I'll move forward. So the next container that we'll be learning about is set. Set just basically stores unique values in a sorted order. So and if suppose we have the set and we want to search for an element or remove an element or insert another element, all of this takes time and complexity of big of log n. Another thing about set is sets work on any data type. You can have a set of integers, you can have a set of characters, you can have a set of strings. Any data type that has a less than function implemented, that has a comparison function implemented. Uh, you can also implement your own comparison function by using this code. So this is something that you won't need to do. This is something that you just need to know. You won't really be applying this, especially at the start. The comparator thing. Set is important.
Here, like, what does this line means? Data type must have less than function implemented. Like,
So all the inbuilt data types do have a less than function implemented, but suppose you create your own data type. You know how to create your own data type? You won't need to do this, but sometimes we do create our own data types, like using struct or class, etc. There's
yes,
nothing.
yes.
So if you want to have a set of your own class or your own struct, you have to implement the less than function.
Okay.
This.
Basically,
Hmm.
means, it means in set they should be they can be compared. Like
Ha
data
ha.
type must be that.
Yes, yes. It's an obvious thing, right? If you want something in sorted order, there should be a comparison
Yes,
between
yes,
two
yes.
elements.
Okay, okay, okay.
So I'll just show you the code for set. Uh, as I said, a set can be for any data type that has a less than that can be compared. So, for example, you can compare two strings, right? You can see which string is lexicographically small, which string is lexicographically larger. So here I have taken n as 3 and initialized the set as this. The data type will come here. For every container, the data type will come like this inside the triangle bracket. So within the for loop, I'm inserting at the element one by one inside the set using this function s.insert. And then similarly, as I had done before, this iterator, as I had explained, iterator, it works for every container in STL. It's not just for vectors, all right? So we'll run this code. Any doubt in the code?
Excuse me.
Hmm.
While we are inserting the values one by one, so it's getting added at the last position, right? So if after that, if I write like s dot insert, giving a position, let's say 2 comma a value 10.
Hmm.
So at the position of 2, the value will get inserted, and the rest of the values will just shift or what?
So sets do not really have a position. The only it always gets sorted as you insert the values. So if it has 1, 3, and 4, a set has 1, 3, and 4, and you insert 2, the the set will be 1, 2, 3, 4. It will always store in the sorted order. It will always sort itself every time you insert a number.
No, I'm not talking about sorting. I'm just talking about the inserting part. Like if I want to insert the value
Mhm.
at certain at a particular position, so it
The
will get
position
inserted.
the position that you want. right?
The position that I
That
want.
you
So the rest,
that you can do inside. You have a vector for that, right? You can do
no,
that with
the
vectors.
okay. I'm just wondering that the rest of the elements will shift or what? I mean the position. Let's say कि वो पहले से ही occupied था by some other value. तो अगर उस
हाँ, I
पोजीशन पे
got
मैं
it, I
कोई
got it.
और
हाँ, I
हाँ
got
वो
it.
पूछ रही हूँ मैं तो
हाँ, that though they will shift. They will
ओके
shift.
ओके वही वही पूछ रही थी
Hmm.
ओके
So this was about set. Any other doubt in set? Related to sets are unordered sets. Unordered sets are same as sets, but they do not store the values in sorted order. Unordered, you'll use unordered set quite rarely. Most of the time, you'll use set. The advantage of unordered set is complexity. You don't have a big O log n complexity for it. You have the complexity of big O1 for search, removal, and insertion. Also, for an ordered set, you don't have to use a comparator function because obviously nothing is being compared. It's not really storing the elements in a sorted order, but you have to have a hash function implemented. You'll learn more about hash function later. So unordered set can store these type of values, pairs, vectors, or other data types that do not have a hash function, but it can store integers. Uh, So next is map. Next container that we'll use is map. Map is uh, map is quite important to solve problems. It has many uses. Uh, so the basic function of map is just an extension of vector of so in vector what we do is we have the index, but the index is always a position, right? Always a number, and that too within a fixed range, right? So isn't that a restriction that you can only have index as a number from 0 to 5? What if you want the index to be a character or a string or anything, any data type? So for that purpose we use a map. So similar to a set, maps are sorted by keys. Again, search, removal, and insertion of elements have the complexity of log n. As I said, they can have any value as index. Again, as we saw in set, the data type has to have a comparison function implemented. And similar to a set, we can pass a custom comparator. So I'll just show you the code for map. Uh, Here I am taking the input as a single string, and here I have declared the map. So map obviously takes two data types, the one that is for the index and one that is for the output, the value that's storing, index and value, index value pairs, right? Any doubt in the initialization?
No, it's clear.
Hmm. Okay, so here I've typed the for loop, and I'm incrementing. Basically, what I'm doing in the code is storing the count of the characters in the string. So I'm taking the character as index and incrementing the value one by one for every character, and then again, uh, as I had done before, I'm taking the iterator. This is the short version of the code that I've written, right? All this. This is the short version for it.
I want to ask one thing in
Hmm.
the second last line.
Hmm.
Like we have written here, int I equals to 0, I less than s dot size. So I means what? Like it has two values, as you said, index and value. So uh,
I is for the string. We are using I for the positions in the string. I is not for the map.
I is not for the map.
Yes.
So I is increasing. Like what, like S is string.
Yes.
So
So
no, I did not get it.
yes, I'll explain you. So suppose the string is this is our string. So when I is equal to 0,
Just take
s
another
of I.
value.
Okay,
Take
will
another
become
value.
confusing, right? We'll have this. So s of what will be I will be 0 for the first step. So what will be s of I? S of I will be for the first iteration of the for loop when I equal to 0.
P.
P, right? So what will be m of s of I as I've written in the code?
1.
Right. M of s of I will be m of p. As I said, the index will be the character, right? And this will get incremented to 1. Is it clear now?
Yeah.
Hmm.
So if a letter is like twice or thrice,
Yes, it will get incremented again.
so where it will get stored in the map.
Yes, in the map.
Okay. So like P, if P is twice, so P beside that it would be 2. That's right.
Yes, yes.
Okay.
Yes, that is the purpose of the map.
Okay.
Hmm. And here I am taking the output of the map like this. First, I
Um,
dot.
okay, okay, you explain this.
I dot first is the index and I dot second is the value. This is how we output the index and the value. So I'll take the output of it.
What is here? I means auto I in M. So I is here representing what in the last code of line.
The value of the iterator. I represents the value of the iterator. So
Uh,
as I had here, ID represented the iterator, right?
yes.
So I represent the value of the iterator. So that's why I have not taken the value of operator here, right? I have just written I dot first because the value is already there in I. All right.
So like I is what the iterator.
Value that's stored in the iterator.
Okay, a value that is stored at the iterator.
Hmm.
Okay, that's why we didn't take star of
Yes,
I.
yes, yes, yes. Similarly, for vectors, you can do like this. All this that I have written, you can just do this. For auto I, so as you can see, I have not written the value of operator. It will have the same output.
So it will output all the values in that vector.
In that,
The I.
yes, any container, vector,
I mean,
set map. Yes.
okay, okay.
So, so as you can see, the indexes are sorted in the alphabetical order, and R has the value too because R is coming twice. It's basically storing the count. So here I have basically taken the output of all the characters in the map. That's why I have used iterator. So what if we want to output the count of a single character? Can anyone tell me the code? What will we see out? What will we see out? Output of a fixed single character. Suppose R.
Then I think M of bracket
M of R.
in,
Yes.
in quotes are M of R. Yes,
Yes.
exactly.
Right. So this was about map. Any doubts in the map? So similar to a map, we have unordered map. The differences are the same as I said before. It takes less time. It takes order of one time. but it does not sort the elements, and the values have to have hash function implemented. So this was about containers. We want to use some functions on on the containers, right? To make our job easier, so that we do not have to code everything ourselves, and we can have an efficient implementation of the code. So STL functions in general perform some algorithm on one position, an iterator that shows the position or a range. Any doubt in the first sentence? For example, sort performed the function on the range, right? Where where we included L and excluded R. R was the ending iterator, right? So we did not include the ending iterator. We included only the beginning iterator.
Yes.
I'll explain this once more. So suppose we want to sort only the first three elements. So we use a dot begin and a dot begin plus 3. Now a dot begin plus 3 is what position in the vector? Which position in the vector? Because a dot begin is the first position, right?
Fourth position.
Fourth position. So the sort function will not include the ending element. It will include the element before the ending element. That's why there is an open bracket there. So this will sort the first three elements. So similar to the data types, the functions can also have custom comparison functions that can be passed as parameters, and you can also pass the parameter as a value. For example, if we are searching for an element, we need to enter the target as a parameter. So if we have a set of five numbers, and we have to search for suppose three, we'll pass three as a parameter in the search function. These are some useful STL functions. Sort we have already seen. Minimum element returns the iterator, returns the position of the minimum element. Maximum element returns the position of the maximum element. So, I, so tell me, what if in this code I have to take the output of the maximum element? What will I type here? What will I see out? Because min element returns the iterator of the minimum element.
We can store that like position and then we can print it out.
Star of
Then
max element.
directly
Star of max element.
Hmm.
And what will be the parameters?
a dot begin and a dot.
Yes, because these functions work on a range, right? The range that's passed to it.
Hmm.
Reverse is same. It reverses the elements in the vector. Find is used in all the containers if you want to see if a number is present in the vector or not. Again, find takes the range and the value that you want to find. Count returns the count of the value that you want to find in the container. So suppose you pass r in a string, and take the count function, so it will return 2. If the string is program, it will return 2. Fill function is used if you want to fill the container with one value, and iota is if you want to fill the vector with increasing values like 1 2 3 4 5. Similarly, you can see all these functions. You can search for them once in the net. It it also gives the complexity. The complexity is also written, and all the parameters are written. So, which container is best to implement a frequency array?
Maps.
We had used that for that, right? And we have also seen this to sort a vector in reverse. We'll just use reverse and pass in the range as parameters. And then we have to write a comparator for a set to sort in descending order. How will we do that? So a comparator function returns a boolean, right? And it compares two values. This is the basic structure of a comparator function. It returns a boolean and it compares two values that are a and b. It does not need to be int because int already has its comparator function, right? It can be any other data type. But this is the basic structure of a comparator function.
What did you tell about the another data type?
Uh, Here I have written int, right, for the data types that are passed as parameters.
Yes.
The two values that are being
Yes.
compared. The two values that can be of any data type, your custom data type.
Okay.
Hmm. Two
Okay.
vectors,
Okay.
two strings, anything. And you have to return the actual comparison that's being made. So here I have compared the two values directly. I've so if a less than b, it will return 1. The CMP function will return 1, and if a greater than b, the comparator function will return 0. Uh, Here I can really compare anything. So I can type in a less than b plus 5. So this is a different comparator function. This will only return 1 if a is less than b plus 5. This will be used rarely by you. Comparator function won't be used very frequently by you. Okay. These are some example problems. I think we have gone through this in the examples that I had given you. Count characters, yes. We used map for it for this one, right? We had the output like this, and then uh, sorting the array also we had done using vectors. Uh, and then there was this problem. So read it once and tell me the approach.
first we will solve the vector, and then from I equal to 0 till range we will check for like from m element minus m, and then we will keep on incrementing that. And the first element that we don't find, and we pick on that.
Hmm, so this will take a lot of steps, right? Because we have to take the element that we are checking first. We have to start from minus m, and then we have to check in the whole vector, and then we have to take minus m plus 1, and then we have to check that in whole vector. So anything more efficient using STL containers and STL functions. There's a better approach.
Maybe we can try with
Try using
frequency
frequency.
maps, frequency array. So we can create a frequency array for the given n integers,
Hmm.
and then we can check from minus m to m the first value which has count 0.
Hmm.
So that can be done, I think.
Yes, this is a good approach. There's another approach that might be easier. Any other approach? Can you solve this using set? You solve this using vector, and you solve this using map. Can you solve this in set?
uh, Instead of creating an array, we can directly create a set, so it will get sorted out.
Ye-
Yes, and then once we have the set, what will we do?
Then we will check from minus m.
What HTL function will we use to check? How will we check that if minus m is present in the set or not?
We can use find function.
Yes. So we can use find function on every integer after minus m. So another approach using set that uses different functions if you don't want to use a find function is that just store all the integers from minus m to m in a set, and then as you have all the inputs, all the numbers in A, just remove the elements one by one from the set, right?
So basically, like for find also or remove also, we would have to do a loop only from minus m to m. because for find function we have to give the input, right? Find minus m or find minus m plus 1,
Yes, yes, the
and if
complexity
it's not there,
complexity will be the same. It is just another approach.
means
Hmm.
like if we use a frequency array also, then also I think similar approach only. I mean we
Yes,
are just
yes.
finding it only.
Yes, yes, the complexities are the same. These are
Okay,
the
that only I was
different approaches that use different functions.
okay,
Hmm.
yeah.
And then when all the elements that are in A are removed, we can just use s dot begin, star s dot begin, because that will give us the element at the first position, right, in the set, star s dot begin, and the first position will obviously be the smallest number. The sets are sorted, right?
Okay, we are removing the elements from first we create a set from minus m to m, all the values, and then we remove the elements one by one from I mean, using the integers that we are, these n integers we are removing from the set of minus m to m, right?
Right. Hmm.
That we're doing. Okay, okay.
Hmm.
And then the last element remaining is our answer.
Hmm.
Yes. Okay.
Sir, why the last one remaining?
Why the yes, yes,
The
first
first
element.
position, right?
Hmm.
Okay.
The smallest number right in the
Yeah, the
set.
first one. Okay.
Hmm.
Yeah, yeah.
So these are some resources. I'll send you these resources in the chat for learning more STL containers and more STL algorithms. Try to learn about multiset and multimap. These are very similar to set and map, and uh, the the functions that I told you, they are the what, just 5 to 10% of the functions available in STL. There are a lot of functions that you can use to perform various tasks that save you a lot of time. Okay, so this was about HTML. Any questions?
The resources can you provide in the like WhatsApp group?
Yes, yes, I'll do that.